Okay, here's some more notes from section 5.2, and these were some definitions or some concepts that were given over on page 279. And remember we talked about the area, and the area of these rectangles, the heights are determined by the value of the function. So if the function is below the axis, we'll end up with a negative number. So the concept of negative area is a little bit kind of like velocity. In other words, velocity, when you're moving to the right, your velocity is positive. When you're moving to the left, your velocity is negative. And the same idea, if the area is above the curve, or above the x-axis, pardon me, if the area of the curve is above the x-axis, the area is positive, considered to be positive. And if the area is below the x-axis, it's considered to be negative. All right? It's really hard to talk about a negative area, but that's basically, it's where it is, kind of like a negative velocity. Of course, that's a little bit easier to understand going backwards, but negative area, it's just area that's under the graph. Okay? So the area equals the negation, or the negative, of the value of this definite integral when a definite integral is less than 0. In other words, when I'm below the curve, or when I'm below the x-axis, pardon me, excuse me, when the curve is below the x-axis, all right, okay, then the area that you have will be the negative of the integral, all right? That's what they're saying. So the area will be the negative of the integral. Okay. So if we want to find the value of the integral, we actually basically have to take the negative area. So if I multiply both sides by negative, I would just say negative area equals the value of the integral. I think that's a little bit easier to understand. Okay. And then if we want to find the value of the integral over a interval where it's both positive and negative, then the value of the integral will be the area above the x-axis minus the area below the x-axis. And that's the main idea. Okay? So let's take a look at this, and we can kind of put this to use over here. Let's say we want to evaluate this area of 2x, or we want to evaluate the integral of 2x from -1 to 2. So if I graph the function 2x, the intercept is 0, and the slope is 2, so I go up 2 over 1, up 2 over 1, or back 1 down 2, and this is my y equals 2x. Now I want to evaluate the integral from -1 to 2, and I'm going to use areas. So basically from -1 to 0, I have a triangle that's below the x-axis, and from 1 to 2, I've got a triangle that's above the x-axis. So I can find the area of a triangle. I know how to do that. That's pretty easy. Area of a triangle equals area of a triangle equals 1/2 base times height. Okay, so if we look at this triangle, the area is going to be 1/2, and the base is 1, and the height is 2, because I'm going from -1 down to -2 if I follow this graph. Okay, so the base is 1, and the height is 2. So area of that triangle, let's say area, equals 1/2. Base is 1 times height, which is 2. So that's going to be 1. But since it's below the axis, it's going to be -1. So that's that area, -1, because it's below the axis. So that's what we mean. Not it's going to be a negative area, but that's actually going to be the value of the integral. It's going to be -1, pardon me. Okay, the area is 1, but since it's below the axis, we say the value of that integral from here to here, from -1 to 0, the value of that integral will be just negative the area, or -1. So that's where that works out. Okay, now this triangle over here, area equals 1/2 base times height, and the base is going to be 2, and the height is 4. So that just ends up 1/2 of 2 is 1, 1 times 4 is 4. So this area is +4. So if I take the area above the curve, so if I add these two areas up, well, if I kind of use this form over here, if I call this positive, it's the same thing. But I would add these up because this is going to be equal to 4 minus 1, because that's going to be the area below. I just put a negative there to evaluate that. So we could add these two, or I could think of this either as 4 plus negative 1, or just 4 minus 1, that's going to be 3. That's basically how you would deal with it, okay? We would add these two. If I left this as positive 1, but since it's below the curve, it would be the same idea. So I hope you can that doesn't confuse you, okay? So I would basically add these two values up, or I could think of this as 4 minus positive 1. And that would fall into a little bit more of what's going on here, okay? So that's how you deal with these. So if you have some of the curves that are going above and below, whatever is above is positive, whatever is below is negative, just add them all up. Okay? And then we had another concept here that we need to kind of cover, and that's the integral of a constant. If f of x equals c, where c is a constant, on the interval from a to b, then the integral from a to b of f of x is just the integral from a to b of c dx, which is just c times the difference between the upper limit and the lower limit, or the upper limit minus the lower limit. And here's kind of an example, or kind of an illustration. If my f of x is 2, which is a constant, and I want to evaluate the integral from 1 to 4 of f of x, well, that's just going to be the area of this rectangle, okay, which is just going to be 3 times 2. Well, that's the same thing as 4 minus 1 would give me the length of the base of this rectangle, because this is 4 units, this is 1, and this is the b minus a, as that's going to give me just 3, and times the constant value. So the value of this integral would be just 2 times 4 minus 1, which is just 2 times 3, which is 6, and you can see that the area of that rectangle is 6. Okay, and then if we look over here, there's another example. If I want to evaluate the integral from 1 to 4 of 6 dx, this is the constant. This is going to be 6 times the difference between 4 and 1. 4 minus 1 is going to be 3, so 6 times 3 equals 18. All right? And here's a little bit more complicated arithmetic one. The integral from negative 1.2 to 4.7 times of 0.4, that's my constant value dx. So that's just going to be the constant value, 0.4, times the difference. So that's going to be 4.7 minus a negative 1.2. So now we've got double negatives. That's going to be the same thing as 4.7 times, 4.7 plus 1.2, which is 5.9. And if I multiplied 0.4 times 5.9, I'd get 4 times 9 is 36, carry a 3, 23, carry your 2, 23 point. And with two places, 1, 2 to the right of the decimal point, I get 2.36. All right, so there's a couple of examples of how to deal with that integral of a constant. Okay, I hope those help.